Hello everyone, this is Rakesh Kushwaha from Mumbai. Let us continue integration. This is part 2. So, an integration function which is in the form of 1 upon x or 1 upon ax plus b. Like if you remember when we were doing differentiating log ax plus b, we were writing this a as numerator, so a upon ax plus b, where ax plus b should not be 0. So what is ln here? Ln is natural log and it is with base e. The value of e is what? Irrational number and transcendental number, which is 2.718. This is for your reference. 2.718 is the value of e, and in higher mathematics the natural log is log only. We generally call it log. So now when we are dealing with integration, 1 upon x, the integration of 1 upon x is log x. Simple. And the integration of 1 upon ax plus b, so we write 1 upon a. This becomes your denominator. Let us begin with the sum. So 5 upon x, first of all 5 you will take out, here you will take 6 out, and here you will take 8 out. So now when we take these things out, here nothing is ax, so a is 1 here, so you will write upon 1, and here there is 2 and there is minus 4. You have to remember all this. So now let us start with the first one, 5 upon x. So 1 upon 5 into 1 upon x, and 1 upon x means log x. So simple. So 5 log x is your answer. When we come with b part, 6 you have taken out and 2 is the coefficient of x. So you will write 1 upon 2x plus 5. So you will write 1 upon 2 as like the log of, so you will make the denominator 2. So 1 upon 2 log 2x plus, as I told you, ax. So a we take out, we write 1 upon a and then log. So same thing we are doing. So here we are writing 1 upon 2 and log 2x plus 5. Here let us see, I am giving 3 similar examples. So first of all we have taken 8 out, and then minus 4 is the coefficient of x, so we will take 1 upon minus 4, and then we will simplify. This can cancel, so 4 2s are, and that 2 negative, so minus 2 log, and that is your answer. When we go for further indefinite integration, so the concept is the reverse, as we know. So when we are doing differentiating like fx, and we can get the reverse, so small fx becomes this capital. After integration we get the same function, okay, but with c plus c. So here we have to show that the value of this differentiation is this. So we can assume this part as y and we can differentiate it, and let us see. And then we have to find the value of 3x square minus 3x minus 1 upon square root 4x minus 3 the whole cube. So this 2 is not there when we are proving, or we are finding the value. Let us start. So we will assume this x square plus 1 upon root square root 4x minus 3 as y, and then we can apply u upon v method. So what is your u upon v method when we differentiate? So v into du upon dx minus u dv upon dx upon v square. So we have applied. So v square means this square root goes away. Square root of x square is x. So same way this 4x minus 3 we get because it is square of square root. Then we simplify. So here we have written 2x outside, and then we have just written this negative 1 upon 2 is square root down. So when you get x raised to minus 1 upon 2, you can write 1 upon square root x, like that. So here we have taken it down, and here we have written 2 because we have written 2 and x square plus 1 upon root this thing has, because there is 4, so if you see this 4 we have cancelled with this, so it is 2, so 2x square and this 2 we have brought here, so 2x square plus 1 upon root 4x minus 3. Why this root has come? Because this was degree was -12. And now you can simplify. So when you take LCM, 4x minus 1, it goes here. So when you multiply root x into root x, root gets removed, it becomes x. Same way here you get 4x minus 3, and then down is, this comes down. So you get 4x plus minus 3 into root 4x minus 3. So x into root x becomes x raised to 3 upon 2 or 1.5. Please follow what I said. X into root x. It means x raised to 1 into x raised to 1 upon 2. So you can say x raised to 3 upon 2. So same thing we have done here. We have written 3. So square root of 3, because you can write square root x cube, which is x raised to 3 upon 2. So we have written cube of square root of this, and then 3x square. We can add x square is negative and this x square is positive. Please focus, you can try by yourself, and we got the answer. So we got this dy upon dx, and now they are asking integrate it and integrate without 2. So what we did, this we have taken 2 multiply here and divide by here, so we'll get our value, because we want in integration this. So this we have taken out because they wanted the answer without 2. Okay, so 2 we have taken out, it means this is gone, like that. So we can find the value. Our answer is x square plus 1 upon root 4x minus 3, because this 2 is gone from here and it has come here. Easy. Now differentiate x sin x with respect to x, and then you find x cos x. They give you the answer also. So assume that y is x sin x, and how product rule used to say, differentiate, first you write u and differentiate v, and then write v differentiate u. So x into differentiating sin x becomes cos x, and then sin x into x. So when we differentiate x becomes 1. X becomes 1. So it is recap for your differentiation also. Now we have written in simple form. Now integrate it. So when we integrate, so you can integrate x cos x plus sin x dx equal to, you can write sin x. You can write sin x. Now separate them, because they want x cos x. They want only this much. So separate them. Two functions can be separated. You write integration for both, and this you can shift that side, because I want to make subject this. So when I integrate this sin x, it is already negative, so sin x is minus cos x, and this is our answer. Let us go for complicated one now. Differentiate this with respect to x and find the value. So they give you answer, actually find the value means it will come after differentiation. So you have assumed y like before, and this is again UV method. So u into differentiate v plus v into differentiate u, and then you will get this answer. And now you can take the integration, as I told you. So in integration you can take degree, you can separate them. So plus 5 you can separate, because there is no plus 5 here, and this you can keep isolated, and then you can get the value. You can replace the value. 7x cube minus 3x square upon root x, this value matches here, so you can write this value x cube and this, and then you can integrate it. You remember, like this coefficient of x used to become like your denominator, and here's degree half, so we add 1, so minus half plus 1 will give you positive half. So this positive half has become degree, and same has become the denominator, and this 2 has come here, so 2 and 2 got cancelled, and you got this answer. You can pause the video and have focus more, because if I explain each and every step, then the video will become lengthy one. Definite integration. So the difference between indefinite and definite, you have many solutions, and in definite you have only one solution, because there is range given here. 1 to 4 is the range, so limit 1 to 4. So when the formula is a to b, fx dx means we separate them, we substitute b first and then minus a first. So this is fx. When we integrate, we get the value, and if there is constant, we take it out and then we integrate. So same method we are applying. Let us start the question, you will understand. So here the range is 1 to 2, the limit is 1 to 2, and you are integrating x raised to 5 plus 3 upon x square. Simple. So this x square you divide first. So when you divide, it will become x raised to 5 minus 2, and this will become 3x raised to minus 2, or 3 upon x square. Now you can integrate them. So x cube becomes x4 upon 4. This is recap. And here you have to add degree. So when you add 1, it will be minus 1. So x raised to minus 1 upon minus 1. And then you can simplify. So you got, and then you can substitute the value. First you substitute 2 instead of x, so it becomes 16 upon 4, which is 4. 2 raised to 4 is 16. These are small things, and 16 upon 4 is 4. And here 2 raised to minus 1, so 2 raised to minus 1, you will write 1 upon 2, and so it became 3 upon 2. It became 3 upon 2. And here 1 raised to 4 is 1, so 1 upon 4 minus 3. Because 1 raised to any gives you 1 only. Now here this is square root, so you can write degree 1 upon 2, and then now you apply your method. So if you remember, this becomes your denominator. So I have taken this denominator here, and then you increase degree by 1 and write here. So this degree and this matches, and then we are using the limit. First we will substitute 5 and then we will substitute 0. So it is 2 upon 9, because it was 9 upon 2. So 1 upon 9 upon 2 becomes 2 upon 9. So substitute the value. So 3x plus 1. So you write 3 into 5. 3 into 5 plus 1. So it becomes 15 plus 1. 16. So that we got, that way they got 16. So 16 raised to 3 upon 2, and then you can simplify it. You will get your answer. When we come here, 10. So 10 you can take out, and 3 minus 2x raised to minus 2, because we are shifting it up. So degree becomes negative. And then you can simply get the solution. So substitute the values, integrate first. So minus 2 plus 1 will give you minus 1, and which will become denominator also. And there the coefficient of x was minus 2, so minus 2 is already here. And then we simplify. So when you cancel, you got 5, because it is 10 upon 2, because minus 2 into minus 1, so you got 5. And here 5 upon 2x minus, because this is 3 minus 2x raised to minus 1, which will give you 1 upon 3 minus 2x. Substitute the value. 1 time 1 and 1 time minus 1. So you will get 5 minus, answer is 5 minus 1, which gives you 4. Let us go for little complicated. Now this is your exponential, this is your e. So if you remember, e was as it is, only this 2 comes out, so as denominator, sorry, so 4 upon 2. And there we write as it is, it doesn't change, only this 2 comes here, and then we got the answer. Substitute the value of x as 2 and 1. Here the range is 0 to pi by 4. Pi by 4 means 180 upon 4, so 45 degree. If you are just radian and degree, if you are confused, pi is 180 degree. Pi means 180 degree here. So 3 into cos 2x plus 5. So you can write here, integrate here. So what we will do, this 5 will become 5x and 3, and this 2 becomes denominator, so 3 upon 2. 3 is out and cos 2x is sin 2x, and then you substitute the value. So x becomes pi upon 4 in one time and second time 0. Okay, so sin pi upon 2 is 1, so 3 upon 2 into 1 will give you 3 upon 2, and sin 0 is 0. And when we simplified, we got the answer. You can take LCM 4, so it becomes 6. This is your answer. You can pause the video and follow the steps slowly. Here we know this is log 1 upon x, integration is log x, log modulus x, because it may give you negative and positive both. So here we are learning modulus sign in integration. So here 1 upon x, so it remains 1 upon a only outside, and then we write log as it is. So let us see the range. Only the difference is here you have been given the limit 2 to 3, otherwise the sums are similar, which we have done in part 1. So 8 upon 2 log 2x plus 1. So 8 upon 2 we have taken upon 2 because the coefficient of this ax plus b, it became the coefficient here, and then you have written log 2x plus 1, and then substitute the value of 2. So 2x plus 1, if you substitute 3, becomes 3 into 2, so 7. 2 into 3 plus 1, so 7. Same way here, when you substitute 2, and you get log 7 minus log 5. So if you know the log rules, log x upon y is log x minus log y. So same thing we have written here. So log 7 minus log 5 means log 7 upon 5. Here 9 upon 2 minus 3x. Remember, this minus 3x is, minus 3 is the coefficient, so this becomes denominator, and we write log as it is. 9 is outside, and then the range 5 and 3 is the limit. So substitute 5. So 2 minus 3 into 5. Simple, so 2 minus 15. So you get minus 13. Some learners don't get the simple calculation. You can try by yourself. And when you substitute 3, you get 2 minus 3 into 3. So 2 minus 9, which gives you minus 7. And again you got log 7 minus log 13, which you can write 7 upon 13. Thank you very much. If you like the video, please share with your contacts for a social cause. May God bless you.